Morning all, and today I will be taking analytical chemistry, that is block 4, which is chromatography. Today's unit is chromatography. In the unit 13 we are going to discuss the chromatography, what is chromatography and types of chromatography and the application of chromatography. So what is chromatography? Chromatography is nothing but it is an analytical technique. It is widely used for separation, isolation, and identification of chemical components of a complex mixture. So it is mainly used for the separation of the mixture. If one component is there, you don't need to use the chromatographic technique to separate. If the mixture of components to separate, you use chromatography over here. So mainly such as separation of amino acids, sugar, vitamins, hormones, plant pigments, phytoconstituents, and organic synthesized compounds. Whether if you get the byproducts, we are going to separate using chromatographic technique. And again, chromatography is a analytical technique which is used for separation. So here the chromatographic technique, by using chromatography technique, we are going to identify, we'll get different bands. So that is known as chromatogram. And this method is known as chromatographic technique. So here the column we are going to use for separation of the compounds. Compounds are known as stationary phase, and we are going to use some of the solvents to separate those mixture. That is known as mobile phase, which is going to move from top to flowing through the absorbent and eluted by some of the components with different time intervals. So it is a physical method for separation of mixture of solutes. Solutes are nothing but the given mixture, that is known as solutes. Here there are different methods which involve these following steps. The first method is adsorption or retention of substance of the stationary phase. The stationary phase, what you are given in the next one. Wait a second, I have made one slide. I will show you that. Yes, in this, the first step is adsorption or retention of substance. You are going, the mixture what you are injected to the column is absorbed by the stationary phase. The stationary phase is nothing but the absorbent. Absorbent, we are going to use different absorbents such as silica gel, alumina, which is used as a absorbent here. And the mobile phase is nothing but the solution, different solutions. We are going to use polar and non-polar solutions to elute the given sample and separate the mixture. So second one is the separation of the absorbed substance by mobile phase. And the third step is recovery of the separated substance by continuous flow or mobile phase. You are going to recover the solvent by drying using rotoevaporator to recover the solvent by separating the given sample. And the fourth step is qualitative and quantitative analysis of the eluted substance. Which one? The given sample is eluted, means it is separated. This is known as eluted substance. So you are going to analyze the after chromatography technique. You are going to analyze the sample by qualitative and quantitative method. Means qualitative, the purity of the given sample, and the quantitative is nothing but the quantity of the how much quantity it is present in the given mixture. You are going to analyze by chromatographic technique. And there is classification of chromatographic method. You are going to classify into different methods here. In the first method, the stationary phase may be either solid or liquid, whatever the present in the column. I'm showing the next slide. Present in the column, it may be solid or liquid. That is known as stationary phase. Either it may be in the solid or liquid, and the mobile phase may be in the liquid or gas medium. Here, different types. In the first type, um, mobile phase will be in the liquid, and stationary phase is in the solid form. And the second type is mobile phase in the liquid, and stationary phase also is in the liquid. And the third type is mobile phase in the gas and stationary phase in the solid. In the fourth type, mobile phase is in the gas phase and the stationary phase in the liquid form. So here what you are going to cleanly observe from this means the mobile phase only can it may be in the liquid or gas. It cannot be solid form. Why means it should move from the top of the form and passes through the sample, and it should be get eluted. So this is known as mobile phase, and stationary phase may be in the liquid or solid form. These are the four types of chromatography, and further this can be differentiated is, see, liquid solid phase, liquid phase, gas liquid means nothing, and gas solid and gas liquid form. Liquid solid means liquid is in the stationary mobile phase, and solid is in the stationary phase. Here liquid means liquid also liquid is in mobile phase, and another liquid is in the stationary phase. And here gas is in the stationary mobile phase, and solid is in the stationary phase. Here gas is in the mobile phase and liquid is in the stationary phase. Fourth type. And further, the classification based on the chemical or physical mechanism. Here LSC is liquid solid chromatography, and first type, and second type is LLC is liquid chromatography, and the third type is gas solid chromatography, that is known as GSC. And in the LSC liquid solid chromatography, it can be column types of chromatography is used here. Column chromatography used here, and ion exchange chromatography. In the liquid chromatography, it will be paper chromatography, partition chromatography can be used, and further in the gas solid chromatography, different types like adsorption chromatography, gas mobile phase chromatography, gas liquid chromatography are used here. These are the types on the based on the stationary and mobile phase. Different types of chromatographies are used for the separating of given mixture. Here, the theory and principle of column chromatography. This is the first type of chromatography what we are going to use. In this method, the column chromatography stationary phase is liquid and mobile phase will be in liquid. So, or it may be also solid also. Uh, uh, from this plot, we are going to, this is the chromatogram, what we have got after eluting the sample. This A refers to the compound A and B refers to the peak of compound B. This is the chromatogram what we have got from this column chromatography. This chromatogram is analyzed by using detectors. This peak, this refers to the compound A, and this is for the compound B. And here we are going to calculate these values, the quantity and quality can be measured by using retention factor. Retention factor is nothing but the time taken for the compound to elute. That is known as retention factor, and this retention time is the time elapsed for the introduction of the solute to the peak. That is known as retention time, and the time required to elute the non-retained components is known as column time. And further, it can be calculated using V is equal to L by TR. TR is the retention time, and further TM is the time void time, and W is the baseline base width. Here, if you analyze, see, this is the peak for the compound A, and this is the peak for the compound B. So TR is the retention time, and this is the time what you are going to with the detector time. This is known as time. You are going to calculate the retention time. This is known as retention. R factor you need to calculate from this plot, or it is known as chromatogram. And this is the base width of this compound A, and this is the base width of the compound B. Then that will be denoted as WA and WB. So TM is known as void time, time taken for the compound to separate. So here at the time 0, the compound is injected to the column, and from this we are going to determine the chromatographic resolution. The main goal of the chromatography is to separate the sample by series of chromatography peaks. Whatever the peaks we have determined for different samples. This is for the sample A, and this is for the sample B. So here the degree of separation between two chromatographic peaks increases with increase in delta TR, with delta retention time is increased means the degree of separation of the time for the separation also increases. It takes more time for the separating of the compounds as the solute passes through the chromatography, and increasing delta TR. And the second is by decreasing the baseline, we may increase the delta TR. by it may increase means time for retention time may be increased by decreasing the bandwidth means baseline width of the given chromatogram. And further, the factors governing for column chromatography. What are the main factors which is affecting the column chromatography? Here, the three main factors which are affecting the column chromatography is migration rate, partition ratio, and capacity factors. The distribution of the solute between the mobile phase and stationary phase are reported by equilibrium reaction. When it is distributed equally, it is in the equilibrium. So the equilibrium constant, it is denoted by K. And further reaction is this reaction is known as partition ratio. This is the one of the factor which is governing for the efficiency of the column. And further, C is the mole analytical concentration, where the for the stationary phase, and CM is denoted as the analytical concentration of the solution in the mobile phase. Uh, Further, next point is significance of the capacity factors, which is denoted as K. If the K is less than 1, the determination of reaction time becomes, which is rapid. If the reaction is taking fast, means it is in K is less than 1 means the reaction is rapid. If K lies between 1 to 5, the elution time becomes inordinately long. Means it takes more time for the eluting of the sample. So when K lies in the range of 1 to 5, the reaction is in the stationary. And further, we are going, next topic is column efficiency. Here need to study column efficiency. Column efficiency can be defined in terms of different numbers on the theoretical plates, or the sum of the height of theoretical plates. The column efficiency can be, see, missed one. The height of the column by different bands or theoretical plates here. The successful separation of components of the sample using column chromatography are the nature of the absorbent. Whatever the absorbent is, nothing but the stationary phase, what we have used here, such as silica gel, alumina, different absorbent are used for the different samples what we are taking to separate. So it depends on the nature of the absorbent, and second, the nature of the solvent used to elute the sample. That is, solvent is nothing but the mobile phase which we are going to use here, whether it be polar or non-polar solvents such as pet ether, petroleum ether, ethanol, water, different. We are going to use different mixture combinations to separate the sample. The rate of flow of the solvent through the column also matters here, on which rate the solvent is flowing in the column, so that the elution of the sample also it takes time. And further it depends on the temperature and geometry of the column containing absorbent. In what this the column, it depends on the geometry of the column also. And this is the tendency with different absorbent. We are going to separate acid base. What are the components we can separate? Acid base, different alcohols, aldehydes, unsaturated hydrocarbons, and saturated hydrocarbons we are going to use for the separation. And further we are going to move to the experimental setup. Mm, this is the what I told explained in the previous. This is the column. It will be size of the column will be little what you have used, what you have taken burette. It will be less, means the diameter is maybe 1 centimeter of the burette what you have taken, but it will for this 2 to 5 centimeters the size of the column will be. The diameter will be around 2 to 5 centimeter, which is bigger. Same it as burette. For that, we are going to use cotton or glass wool here for the separation. Further, we are going to use the packing material. Packing material is nothing but the stationary phase. Stationary phase is absorbent. Absorbent means we are going to use silica gel or alumina or different absorbents you are going to use. And further, we are going to add the this in this you can, yes, this is the absorbent area, and here we are going to add glass wool or cotton we are going to use to for the separation. Further, this is the solution. This is known as mobile phase. Mobile phase is nothing but the solvents which you are going to use for the separation, and absorbent is the stationary phase. So this band is known as the samples which need to be separated, whether it is a phytoconstituents or synthesized organic compounds or molecules, etc. It's a mixture. First, we are going to add the mixture which needs to be separated, and further we are going to add starting of solution, that is mobile phase, using reservoirs. Reservoir is nothing but the solution which is in the large quantity which is used and further added, and the mobile phase moves through absorbent, through sample and absorbent, and the primary with the different concentration of the mobile phase with the polar and non-polar solvent. We can take it in the 1:2 concentration, 1:3, for varying the different concentration of the solvents. The different samples are going to observe here, and further through wool we are going to collect in the different flask, so that with the different here different bands are observed for the different ratios of the solvent passing through the columns. So we are going to collude this is the elute of the sample with the given solvent. This is this we are going to evaporate the solvent, and further we are going to collect the different samples. This is the basic technique used in the chromatography, column chromatography. And we are going to study the this the experimental setup, and here we are going to use glass tube. And this is the flash filter, and this is the reservoirs. These are the experimental setup used for the column chromatography. And coming to the packing, yes, while packing there are two types of packing, that is wet packing and dry packing. In the wet packing, we are going to use some solvents and dissolve the absorbent like silica gel, alumina. We are going to by using of the solvent you are going to pour, and that going to settle down here. That is known as wet packing. Dry packing means directly we are going to use silica gel or anything to the column. So that is known as dry packing. And further, the development of chromatography is nothing but you are going to get different bands. That different bands are known as the development of chromatogram. Uh, this is the experimental technique used for the separation of the given samples. And further, the application of column chromatography. The main applications of column chromatography is to separate the mixture into pure individual components. So this is the main aim of this column chromatography. And further, the purification of compounds by removal of small amount of contamination or some it can be used for the purification of compounds also. And further, the determination of homogeneity of the chemical substance to determine the chemical substance of the. Here, how you are going to, from the previous, how you are going to determine the samples by using chromatogram means how you are going, you determine the sample means it can be determined using the RF retention factor. For different compounds, it will be having different retention factor. Standard procedure will be there. Means standard values for the different compounds. On seeing that RF value, we are going to determine that compound is present in that given mixture. So the next point is the comparison of compounds throughout be identical. The compounds which can be compared while flowing in the while collecting in the elute, it will be same. How much the solvent if you pour, the same sample will be separated with different time. So the next is the concentration of the substance. Here the large volume of organic solvents are used. Means it can be used for the to determine the concentration of the substance. Means main it can be for different samples. The concentration of the substance it varies by using different organic solvents. So next is This is second type of chromatography, that is known as paper chromatography. And here two types of force are involved. Uh, in the paper chromatography, that is drop of a solution is applied and it moves upwards, and one type of chromatography, and one more is the downwards. We are going to study in this paper chromatography. It tries to drag the substance while you are spotting the point of the solute or the given mixture. The uh, the given what it may be mobile phase solute is eluted upwards. That takes place in the paper chromatography. In the last column, in the last column chromatography, it moves downwards, right? Whatever the mobile phase added, it moves downwards. In the paper chromatography, the separation of the solutes moves upwards. That is mm, mm, type of paper, that is known in the type of paper chromatography. The solubility of the substance here solvent. The retarding force for the different components of the sample, it migrates with different rates from the original position to depending on the force of the solvents. So from this plot you are going to see this is the paper chromatography, and here this is the line we are going to draw, and we are going to plot the small drop of compound or a mixture or a elute. That is mixture we are going to plot here, and which is kept in the inside the beaker. In the next slide, I think you can get to know. Yes, in this we can observe in the paper chromatography. This is known as paper chromatography. This is the beaker what we have taken, and we are going to plot the mixture of compounds which needs to be separated. Here we'll plot some, we'll take the quantity and we'll plot here, and this mobile phase, this brown color is in the solvent, which is the mobile phase, which moves when it is dipped inside the beaker, which only 5 ml we have taken here on this mobile phase, and this paper is paper chromatogram is inserted inside the beaker, and the when we plot the plot moves upwards here the by the use of what we are going to use solution or solvents what we have taken in the different ratio. It moves upwards, and these points are plotted, or these points are automatically denoted with different compounds. It can be seen here. This technique is known as paper chromatography. Here by we are going to identify the compounds using retention factor For retention factor is nothing but distance traveled by solute. This is the solute. Solute is nothing but the mixture. So distance traveled by the solute. We are going to measure in centimeters by distance traveled by solvent. After this the point what we have got, this the solute, and further this solvent will be moved to upwards till here. This is denoted as solvent and this is denoted as solute. Solute minus the distance, this RF retention factor can be calculated by, see here, distance traveled by the substance from the original line. This distance what the substance is traveled divided by distance traveled by the substance of the compound B. This is known as, we are going to calculate the Rx. For calculating the RF, this is for the calculation of Rx. For calculating the RF, we are going to use distance traveled by the substance or the solute by distance traveled by the solvent. This is the distance traveled the upwards to calculate the RF. Here some of the points are missing in this slide. Wait for a minute. One second. Yes, this is the right slide. Yes, this is the column chromatography what you are going to use. In this technique, see, we are going to get different bands for different compounds. See, you can see here. This is the column what we are going to use, and it is nothing but the size of the column will be nothing more than 3 to 4 times of the burette what you have used. And here packing we are going to use cotton or glass wool, and the mobile phase is from the upwards. You are going to pass the mobile phase, and the mobile phase get observed the sample, and for the different bands we are going to collect different bands over the time, and up till here we are going to collect that is different sample. Further, orange will be collected, that is for different samples. Samples get separated. The mixture of the samples will be separated by different bands, which is formed here. This is known as this the method used for column chromatography. So yeah, yes, this is the right slide. And this in this column chromatography, first stationary phase is nothing but the absorbent, which is silica gel, alumina are used, and the sample is loaded. Further, this green color is the sample what we are going to add for the separation, different mixtures. So further, we are going to add the mobile phase from the upwards. The mobile phase move towards the sample and further to the absorbent, and it is the fraction is collected here, and the samples are while the mobile phase is added, the samples get dissolved in the mobile phase and the different bands are formed in the absorbent area. Further, these bands are separated by visual method. This is the technique used in the column chromatography for the separation of the samples. This is the eluted molecules. For different bands, we are going to separate and collect in the different flask. Coming to the paper chromatography, application of chromatography, actually. In the paper chromatography, will take only small amount of components or mixture, and we are going to plot and here downwards, and we'll immerse this in the beaker. What it is shown here. The mobile phase. The mobile phase is in the beaker. This is the mobile phase, different solvents. The it moves upwards in the paper chromatography, and different bands are formed, A, B, C, D, and different plots are seen. It is formed while the mobile phase moves upwards in the paper chromatography. This RF value, the time for the movement from base to the upwards end of the paper, take the time taken for the movement is determined, and it can be calculated. Further, retention factor can be calculated by the time taken for the solute divided by the distance traveled for the solvent is uh, can be calculated using this paper chromatography. This RF, by getting this RF value, further there is already standard protocol is there. So for the different compounds, for amino acids, latently organic compounds, or phytoconstituents in the extract from the plant, for the different there will be, for different molecules there is a RF value for different. So if the RF value matches with that value, this, so that is the compound present in the given mixture, it can be identified. And further, the technique for the paper chromatography, it mainly depends on the choice of the filter paper used for the separation, to identify the mixture of the compound. For the preparation of solution of the sample, means sample in which solvent you are going to dissolve that sample and plot on the paper, and the application of the sample solution for development of the chromatogram, how the bands are formed in the paper chromatography, and drying of this paper. This paper, filter paper, what we have taken, it should be dried after running the solvent, uh, so that the bands can be visible. Mm. And location of the substance, the paper chromatogram or quantitative chromatogram. Here, it mainly depends on the filter paper. Further, choice of the filter paper should be clarity, and it can be moved. The solvent can be moved easily, and the preparation of the solution. It should be dissolved in the small quantity, and the application of this sample of the paper. For the technique used for the paper chromatography is, it depends on the filter paper, preparation of the solute, means dissolving in the different solution, and the paper also, sample solution for taking the paper, and development of chromatogram, this chromatogram, and drying of paper. Paper should be dried within some degree. It can, that is what we are taken is the filter paper, right? So it cannot be dried in the high temperature. So the location of the substance of paper chromatography or the quantitative estimation for distance travel estimation can be used. And further, the choice of the filter paper, uh, it should be excellent rate of the movement. These are the properties should be having for the choosing of filter paper, and negligible diffusion for the spot developed on the paper due to application of the samples, and clarity of the separation should be there while is selecting the filter paper. These are the properties. And the preparation of the solution should be uh, dissolved in the different by seeing whether it is a polar sample or non-polar compound. Depending on the polarity, we are going to dissolve the samples, given samples. Further application of the samples, here normal application of the sample to the paper means you are going to use 15 to 80 centimeters of the paper, which is immersed in the beaker, filter paper, and further different plots are plotted for the mixture, and different bands are formed while running the mobile phase upwards. The entire process is known as spotting of the compound. Further, the development of chromatogram development is seen here, and here two different types of uh, chromatography is there. One is one-dimensional chromatography, and the second one is two-dimensional chromatography. This one is known as one-dimensional chromatography. Here, mm, this is ascending paper chromatography. Means the mobile phase is moving from lower to higher phase. So this is ascending paper chromatography, and in the descending paper chromatography, uh, the mobile phase moves from the upwards to the lower phase. This is known as the descending phase of paper chromatography. And in this method, the mobile phase is in the reservoirs, and it is dropped by method, and the same as it is, the plots are plotted here, and the mobile phase runs from the above to downwards. This is known as descending paper chromatography. And further, one more method is there, that is radial or circular paper chromatography. This here we are going to use circular paper, which is cutted in the circular type, and here some part of the paper is cut and immersed in this dish, petri dish or beaker, and the chromatogram is formed in the radial form, which is different chromatograms here we can observe. For each compound, different diameters. See, different radials are formed. Circumference. These different circumference are nothing but that for the different bands formed in the circular paper chromatography. This is the technique, one more technique which is used for the separation of the given mixture. For the application of paper chromatography, it is used for the separation of amino acids, amino acids, carbohydrates, etc. And for if the spots are not visually seen, we can use 9-hydrine, which is dipped in the 9-hydrine, so that the spots are formed in the color, so that we can identify such as carbohydrates, aniline, hydrogen. Carbohydrates can be spots. The spots are sprayed to identify the spots, such as chemicals, 9-hydrine and aniline hydrogen peroxide phthalate are used. And in paper chromatography, you have to use some of the organic, some inorganic compounds can be separated using paper chromatography, and this method can be used for the check the purity of the given pharmaceutical drug or food products. This method can be used, and further using for the detection of the drug present in the human can also be used for the by this paper chromatographic method. In this, next is thin layer chromatography. In this method, same it is as it is like a paper chromatography. The material used here is glass. We are going to use here inside of filter paper. We are going to use glass material with dipped in different thin layer chromatography is nothing but we are going to use the glass material, and so we are going to place the spot of the solute, so that in the paper chromatography we have used filter paper for the separation. Here we are going to use the glass and immersed in the different absorbent. So in TLC, an absorbent coated with glass plate serves as a stationary phase. The absorbent is applied on the thin film of the glass. Absorbent is nothing but the silica gel, silicon, or aluminum are used, uh, and it is dried. These glass plates are dried at 110 degrees Celsius, so that it is well attached with the glass. And further, we are going to plot the mixture of the solutes what needs to be separated. And further in the same year also, we are going to run the mobile phase from the lower and it moves upwards. We are going to calculate the retention factor for this distance traveled by the solute divided by distance traveled by the solvent, so that we'll get the retention factor of this technique. See, this is the thin layer chromatography, which is immersed in the beaker or the tank. So tank is nothing but we are going to take the beaker, it's a large beaker, and immerse the TLC. This is known as TLC, and we will closed by the lid upwards, and below the solvent is there. This is known as the mobile phase, and the mobile phase runs from the lower phase to the upper phase. So chromatogram is developed on the chromatoplate, and we are going to identify the location of the compound. So this is the same technique what we are used in the paper chromatography for determining the RF value. Distance moved by the compound from the baseline divided by distance moved by the solvent from the baseline. We are going to divide, we'll get the value of RF. On the value of RF, we are going to identify the compound, which compound is present in the given mixture. So next is the application of this TLC, thin layer chromatography. It is very sensitive. This one TLC is, and compared to the paper chromatography, it is having a better result, and it will show the sharp zones of the point of the uh, chromatogram in the chromatogram, having a better resolution. Further, it can be used for the isolation, purification, and identification of the compounds, phytoconstituents. Uh, it is also used for the purity of the checking of the purity of the compounds, or the organic synthesized compounds. Further, it can be used for the reaction is complete or not, whether the byproducts are formed. It can be used. TLC can be used. It can be used for the serving as identification of the plant extract, phytoconstituents, or the drugs, or the adulteration of the food can be used uh, to determine. Further, it can also be used for the determination of the metal complexes like nickel, cobalt, manganese, zinc. It can be used to determine. And the next one is superiority of TLC over paper chromatography. What is the more benefit? What is the use of TLC than paper chromatography? That is the topic here. We are going. Next point is what are the benefits of TLC or paper chromatography? The time taken for the development of the chromatogram is much shorter for TLC. The development of chromatogram, the spotting of the points are very much faster compared to the paper chromatography in the TLC. In the next is the TLC plates can be dried at high temperature without any risk. Why? In the TLC, we are going to use the material glass. In paper chromatography, we are going to plot on the paper, filter paper. So filter paper cannot be kept in the oven at high degree so that it starts burning. If you keep glass up to 120 degree, nothing will happen. So that drying of the TLC will be much faster, and it can be dried at high temperatures also. This is the advantage of TLC. And the next point is TLC is more sensitive than paper chromatography. The spots can be more sensitive, and it can be
what are the spots, identification of the spots can be more clear, and it will be having purity of the compounds will be identified more easily compared to the paper chromatography. And the capacity of thin layer of the absorbent is higher than the of paper. Here, in the absorbent in the glass, we are going to use some of the absorbents before plotting of the points, because absorbent is nothing but the silica gel or alumina which is used, which pasted on the glass. So there will be absorbent used on the TLC, so the purity can be identified easier. In the paper chromatography, there will be no absorbent. Filter paper itself acts as an absorbent here, so the purity cannot be much mm, more accurate to the compared to the TLC. So next, these are the some of the questions objectives are there. And next unit is we are going to study the gas chromatography. Gas chromatography is nothing but what it is. Gas chromatography is the technique used for the separation. Same it is. But here we are going to use mobile phase. Gas is used as a mobile phase. Uh, that is known as gas chromatography. It is extensively a technique for analytical and industrial purpose. This gas instrument with yes in gas chromatography in the unit 14, you are going to study about the gas chromatography principle and instrumentation of carrier gas, different types of gas used in the gas chromatographic technique, and detectors and temperature used for in the gas chromatography, and factors affecting the retention, peak resolution, peak polarity. So this is the instrument. This is nothing but the gas chromatography. In this gas chromatography, we are using gas or inert gases, helium, hydrogen. What are the different inert gases? Helium, hydrogen, nitrogen, carbon dioxide, argon, krypton, several different inert gases. And depending on the samples, we are going to use different carrier gases for the separation of the compound mixture. So this gas itself acts as a mobile phase here. In the previous column chromatography, we are going to use different solvents for the separation, like polar and non-polar solvents, depending on the mixture. We are going to use in gas chromatography. We are going to use gas as the mobile phase, and here this column, this spirals is known as. These are the column used for the separation. So is widely used in the industry. There are two types of chromatography in gas chromatography, that is known as gas solid chromatography and gas liquid chromatography. In gas solid, gas acts as a mobile phase and solid acts as a stationary phase. In gas liquid chromatography, gas acts as a mobile phase and liquid acts as a stationary phase. So the main principle of this gas chromatography is when a gas or vapor comes in contact with the absorbent, certain amount of it get absorbed on the solid surface. This phenomena is known as gas chromatography. This is the phenomena used in the gas chromatography. And further, the experimental technique here, high pressure cylinders of mobile phase. Mobile phase is known as carrier gases, which is used, and it is inserted by sample injection system. Chromatographic column is used further, and the thermostat column thermostated column means the column is kept in thermostat so that it maintains the temperature, constant temperature for the column. And further it is the column separated, the are detected, the samples are detected using detectors, and further the chromatograms are formed and it is recorded, separated by thermostat, and further strip charts are recorded. So this is the main experimental procedure for the in the gas chromatography. So in carrier gas we are going to use different, it may be helium, hydrogen, different carrier gases are used uh, depending on the sample and the types of detector used for determining the compounds and the efficiency, column efficiency. It also depends on the efficiency on the column, so that we can choose the carrier gas which one has to be used here, and purity also requires, and consumption of hydrogen, helium are most suited for the use with thermal conductivity. Mainly hydrogen and heliums are used as a movable phase in the gas chromatography technique. So in the next, sample injection system. Here it depends, the amount of sample required for the gas chromatography depends on the nature of the concentration of the solute. The solute is nothing but the mixture what you are taken to separate. The size of the column. It also depends on the circumference of the column, and further sensitivity of the detectors, which detectors we are going to use mainly, and further here the injection system, there are three different types of injection, that is known as micro syringe or liquid. Gas samples can be injected, glass and ampoules for the solid samples. For ampoules is nothing as small scale of glass capsule. Amphos is nothing but the small scale of glass capsules which is used for the injection of the solid samples. For gaseous samples, we are going to use wall method. By this methods, we are going to inject the sample to the column. And chromatographic column. Here, mainly gas chromatography are made up of variety of materials such as stainless steel, copper, glass, and plastic, depending upon the mixtures which are taken to separate. And further, column thermostat. For thermostat is nothing but to maintain the constant temperature for the column. And detectors are the device which sends the arrival of the separated components and present in the carrier glass. So further, recorder is nothing but the whatever the detected in the sample, it is recorded, and the mobile recording pen activated by the signal, and the main it is like the chromatogram. Recorder is nothing but the recording of chromatograms in different peaks for the different compounds have been recorded. This is the working, yeah. This is the working procedure. Excuse. Here the carrier glass or gas mobile phase is passed, and the pressure is controlled by valve for the ring of tube. Here the sample is inject, yes, flow regulator, that what rate the gas is flown. Further the sample is injected in the, this the sample. Here we are going to inject the sample which needs to be separated. This is known as the column. This is the column which is running and it is kept in the thermostat. Why you are going to use thermostat? To get the high temperature. Why you need to get the high temperature mean the sample whichever the is injected uh, should be converted to the vapor form so that it mix with the given gas which is in the mobile phase, which combines with the gas, and further it flows through the column, and it is separated. What in the paper, in the column chromatography, by using solvents we have got the different bands, right? In this we are going to get the different samples separated by using detectors. The detector will detect the different samples, and further it is recorded uh, by different. This is the recorder where we will get the chromatogram. Characterization of gas chromatography peak and peak resolution. Here we are going to see the flow rate and the column temperature and the weight of the liquid phase. Liquid phase is nothing but the stationary phase. That is, and we are this is the chromatogram from the gas chromatography, where this is the peak for the compound one compound, and this for the another compound two. So here we are going to calculate the retention with respect to time, retention factors. It is called resolution. So R is denoted by VR2. VR2 is nothing but the detector response, at what time the detector has detected the compound 2. This is known as VR2. VR2 into VR1 for the compound. This is the VR1 with respect to compound 1. This one. This is for the compound 2, divided by time 0.5 into base peak. What is the quantity? W1. This should be W1 into W2, where this W is nothing but the baseline width of the compound 1 and compound 2. So the main condition for factor affecting the resolutions are nature of the stationary phase, and the cross section, length of the column, nature of the linear velocity of the carrier gas, and the phase ratio and the temperature. These are the main which affects the condition of the resolution of the chromatogram. And further, the application of chromatography, gas chromatography, it is mainly used for the separation. All it is generally it used for the separation, like gas chromatography. Separation of two can be accomplished by few methods, and by using molecules. Gas solid chromatography can be used for the separation of mixture of hydrogen, carbon, methane, ethane. Such these are can be separated, and the automobile exhaust gas, which cause mean pollution hazards, have been analyzed by gas liquid chromatography. What are the applications? Yes, study here. Here are some of the application. You can go through this. Uh, this is the end of the unit 14, that is known as gas chromatography. If there is any doubt, kindly ask. I will end the class here so that